Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we introduced interaction terms, the idea that the effect of one variable can depend on another. Now we'll formalize that idea. This is the master formula that governs basically all interaction models. So we will start with the general model where y is equal to beta 0 plus beta 1x plus beta 2z plus beta 3x times z plus an error term u. This is the most general interaction model between two variables, z and x. The key question here is, what is the effect of x on y? Is it just b1? Or is it something else as well? Well, to find the effect of x on y, the most straightforward idea that we have seen so far is, well, we differentiate with respect to x, treating z as a constant. So let's differentiate with respect to x, keeping z constant. In this case, we're going to have delta y divided by delta x, so the derivative, and it's beta 1 plus beta 3z. Okay? So how can we interpret this result? Well, what this is telling you is that the effect of x on y is no longer constant. It actually depends on z. Specifically, let's look at it. When z is equal to 0, that means the effect will be just beta 1. When, let's say, z is equal to 1, that means that the effect is actually beta 1 plus beta 3. But it could be also the case that you've got a z equals to 2, which means that your effect is actually beta 1 plus 2 beta 3. Okay? Now, keep in mind, and this is a little bit of a warning, I am treating at this stage z as continuous. Okay? We'll handle the dummy case shortly, where z can only take the values of 0 or 1. Now, what I want you to take away from these, though, is that this beta 3 that you have in here tells us how the effect of x changes when z is increasing either by a unit or more. So, in a sense, beta 3 is the slope change. And this is the most important interpretation that you have to keep in mind. Now, what if I flipped the question? And what if I wanted to see the effect of z? Well, the effect of z also will depend on x, because here the interaction is two-way. So if you did instead the delta y divided by delta z, so the derivative with respect to z, then what you would have gotten is actually beta 2 plus beta 3x. So symmetrically, in this case, now the effect of z depends also on what the value of x is. So interaction terms allow relationships to vary, and instead of one slope, we now have a slope that depends on another variable. Now, everything we'll do next in the videos that will come up will show very special cases, and we will see where we have an interaction of dummy with a dummy variable. We'll see interactions of a dummy with a continuous variable, and we'll see the case of a continuous variable with a continuous variable. Okay, so all of these three cases are just special cases of this formula. With interactions, the marginal effect of x is beta 1 plus beta 3z. So it depends on another variable. And this is exactly what we will see regardless of which cases we have in terms of the interaction model. Now, if you master this formula and all the other special cases that you have here will easily follow. And once you understand one of them, you'll see also that the application of all of the others will come just as easily. So stay tuned, and we'll see all of these cases in the next few videos.